Zero Trust Network Access, or ZTNA, is all about security that follows the principle of never trust, always verify. Unlike traditional VPNs that provide extensive network access, a zero trust VPN setup ensures users can only reach specific applications or resources based on their identity, device security, and context. In this video, we'll walk through how to configure Access Server to implement ZTNA principles using modern authentication, detailed access policies, and network segmentation. Before we dive into the setup, let's make sure you have everything you need. You should have Access Server installed and running. Version 2.11.0 or later is recommended. You'll also need administrative access to the admin web UI, a modern authentication method like SAML, Radius, or LDAP with multi-factor authentication if you prefer. A segmented network environment with clearly defined resources, and a supported VPN client like OpenVPN Connect for testing. Some basic networking knowledge, like understanding the OSI model and IP addressing, will also be helpful. Now let's break down the core idea behind ZTNA. Every access attempt must be verified, and strict policies must be enforced for every user and device. The first step is to document the applications and resources that need protection, and identify the user groups that require access. This helps ensure that every request is evaluated based on who is trying to connect, from where, and under what conditions. With these principles in mind, we're ready to configure Access Server for ZTNA. Let's get started. Let's start by setting up user authentication in your Access Server. First, sign into the admin web UI. From there, head to Authentication and then Settings. Next, you'll choose your preferred authentication method, whether it's SAML, Radius, or LDAP. You'll need to configure the necessary identity provider details, like the metadata URL and callback settings. If you don't have an external IDP provider like Entra ID or Active Directory, no worries. You can always use the local authentication method instead. To make your setup even more secure, don't forget to enable multi-factor authentication, MFA. This adds an extra layer of protection by requiring users to verify their identity using a second factor like a mobile app. Now let's look at creating user groups and defining access policies. Once authentication is set, it's time to create user groups and define their access policies. You can create groups based on roles or departments like accounting, sales, or IT. For each group, you'll assign specific access policies to control which resources and applications they can access. To grant access to a specific resource, group, or user for a specific set of users, navigate to the Access Control section within the group settings and enable user access control by setting it to Yes. To permit access to networks and services, specify subnets as networks along with bit values, or define services using the network and bit: services. If you want users within a group to communicate with others in the same or different groups, go to Allow Access to Groups and select the appropriate group from the list. To grant access to specific users, find the Allow Access to Users section and select the user you wish to authorize for the group. Once all configurations are complete, click Save Settings and update the running server. Now let's talk about enhancing Zero Trust with post-authentication scripts. To really boost your Zero Trust strategy, Access Server allows you to automate access control decisions using post-authentication scripts. This means you can set dynamic rules to automatically adjust permissions based on a variety of factors after a user logs in. Here are 3 key ways you can extend Zero Trust with post-auth scripting. 1. Automate group mapping for SAML, LDAP, or Radius users. With post-authentication scripts, you can automatically assign users to specific groups based on their directory attributes when they log in via SAML, LDAP, or Radius. Here's how it works. The post-auth script reads the user's attributes from the authentication response. It maps the user to a specific Access Server group automatically. Why is this helpful? It ensures that users only have access to the resources they need. No more manual group assignments. This cuts down on administrative work. Let's say an LDAP user belongs to the accounting department. The script automatically places them in the Accounting Access Server group with specific access policies. Enforce device-based identity verification. You can also enforce device-based identity verification. This requires users to register their devices before they can connect. Here's how it works. The Post-Auth script captures each device's unique identifier, like its MAC address or UUID. Access is granted only if the device matches one that's registered to the user. Implement location-based zero trust access. Another powerful feature is location-based zero trust access. You can restrict access based on IP location, which blocks logins from unknown or untrusted locations. Here's how it works. The Post-Auth script stores known, safe IP addresses for each user. If a login attempt comes from an unrecognized IP, the connection is denied. Why is this important? It prevents unauthorized access from suspicious locations and helps mitigate phishing attacks where attackers might try to log in from new, untrusted locations. A user logging in from a known office location would be granted access, but if they try to log in from another location, the attempt would be blocked. Let's talk about how to implement post-authentication scripts. To set up these advanced security controls in Access Server, you'll follow these steps. First, if you'd like to access the instructions, you can visit our website, openvpn.com, and search for Post-Auth. Then click on Post-Auth Programming Notes and Examples. Here, you'll find step-by-step instructions for each script. For example, let's look at restricted by IP address. On this page, if you scroll down, you'll see all the necessary information and instructions. If you expand Step 2, Install Script, you'll find all the commands you need. Now let's connect to our server. I already have an active SSH session. First, I will retrieve the example Python script using this command. Next, we can edit the script if needed. In our case, we leave it as is to automatically register an IP address for a user when they first authenticate and restricts their access to the registered IP address. So let's exit from here. Finally, we'll reload Access Server. Access Server only allows loading one post-authentication script at a time. If you need multiple functions, like group mapping, hardware registration, and IP location checks, you'll need to combine them into a single Python script. Be sure to structure the logic properly to ensure all functions execute correctly. It is time to test this. As I mentioned earlier, our sample script automatically registers an IP address for a user when they first authenticate and restricts their access to the registered IP address. They're denied access if they sign in from a new IP address. The Post-Auth script learns and locks the IP address for a user who doesn't already have one registered. We are going to log in as one of our users, Matt, for the first time on this machine after loading Post-Auth script. Since this is his first login, his IP address will be registered. After that, he can only log in from this location. If he tries to log in from any other location, his connection will be rejected. We can see Matt was successfully got connected. Let's try from a different machine in a different location. Here is the Connect app, and let's toggle the switch, and here we go. He is not able to connect. As expected, and the last part is monitoring the logs. Regularly review logs and adjust policies to maintain a strict zero trust posture. Now let's talk about implementing network segmentation. To protect sensitive resources, it's important to segment your network and restrict access where needed. Here's how you can do it. Use Access Server's routing and ACL features to control network access. Network Address Translation, or NAT, is the default option for Access Server and works by translating the VPN client's IP address into the Access Server's local private IP. This lets clients access resources like web servers or file servers in the private network, but without exposing the VPN client IPs to the private network. It's a one-way traffic flow, meaning clients can access resources, but the private network can't reach VPN clients. NAT is simple to set up because it doesn't require additional routes. The target system just sees the traffic as local, so everything works smoothly without needing a gateway. Think of it like a firewall. VPN clients are safe from direct access by the private network, but they can still access resources. Routing is an option if you need two-way communication between the private network and VPN clients. With routing, there's no address translation. Access Server forwards traffic from the VPN client subnet directly to the private network. You'll need to set up a static route on the target network's default gateway to tell it where to find the VPN client subnet. This allows traffic to flow in both directions. A pro tip for you: use routing for more complex needs like voice over IP, as it doesn't work well with NAT.